Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today we're going to test interconnects, and we're going to test them and zero in on the test results to see what differences we can see. And I've got a number of interconnect cables here. Let's see if I can grab a few of them. I've got monster cables, timber cable. I've got a cable that cost, I believe it's around 650 US. Okay, so an expensive cable. And then I've got some really inexpensive cables. So I've got things in between. So let's see what difference these cables make. All right, and you might be surprised by the results. Maybe you won't be, but so we're going to look at the frequencies. I think we're going to start at 100 hertz, somewhere around there. All right, guys, so we'll probably start at 10 hertz and go to 40 megahertz. That's the limit of this Bode 100 from Omicron Labs. So, very nice instrument. We're going to go all the way up to 40 meg. We're going to see what the cables do from the low frequencies, which is what audio is, all the way up to the high frequencies, just to see what a cable does and the difference between these cables, okay? And then we're going to zero in on the audio frequency band and see what it looks like there. And we're going to really like zoom in, okay, so we can see any difference there is. And I think you might be surprised by these measurements, but it's basically the gain. So it should be a gain of 0 dB, which is 1 from input, say the output of your preamp to the input of your amplifier, okay? So we want the cable to be transparent. Ideally, what we're going to see is 0 gain, which is gain of 1, and but if there's some losses, but these are small signals, so we don't really expect to see a lot of voltage loss, right? I mean, they're small signals. So usually the input of your audio amplifier is like around a 20k resistor. So I mean, that's a small signal, small amount of current. So we hope to see a gain of close to 1, okay, and which is 0 dB. And then phase, we want it to be flat. We don't want the phase to change. If the phase changes, that means we're seeing reactance. Our impedance would be ideal if it was just resistance. If we just had to put, like, say, a small resistor in our cable, if the input resistance of our amplifier, say 20k ohm, and we wanted to only affect that by 1%, we could go to 2k ohm in the cable, but that's ridiculous. We know it's much less than that. All right, so 200 ohm, so that's what, 0.1%? So what if it's 20 ohm or 2 ohm? You see how nuts it starts to get? If it's 20k ohm at the input, our cable, if it's DC, would be so low in ohms that it would not matter, okay? But is it? We're worried about inductance, we're worried about capacitance, and in some cables, like coax cables, 50 ohm cables, 75 ohm cables, those kind of cables, they call it characteristic impedance. They kind of match the inductance and the capacitance within the cable to get like a 50 ohm Z, all the way across the cable. That's the ideal coax cable. But basically it's 50 ohms impedance to the signal, which is huge in comparison to what our cable really is, So that 50 ohm characteristic impedance, that's generally used for like RF and high frequency stuff. Audio frequencies, not so much. It doesn't really matter so much because, when people talk about skin effect and other effects like that, the insulation, the dielectric of the insulation, that kind of stuff, at our frequencies, audio frequencies, they're just not traveling high enough to come into effect, okay? So, but still, we don't want our cable to be capacitive or inductive, not so much. So we'll test to see how inductive or how capacitive these cables are. The phase will tell us that. The phase is flat, it's DC. If it's curving up or down, it's capacitive or inductive. So let's jump into this video and start testing these cables, okay? Hey guys, all right, so this first test is going to be about gain. And essentially what that means is when we put a cable in here, okay, like for instance, my expensive Oscilloscope cable, okay, when we put this in here, I'm going to use these little gold connectors and gold plated, whatever. And I'm going to put those in here. And these are new connectors I just bought for this test. So we're going to do this. And when we put a signal in here, if we put, let's say 1 volt here, if we see 1 volt there, if we saw 10 volts here, it'd be gain of 10. But if we see 1 volt here, exactly what we saw there, should be gain of 0. We should have 0 gain on this thing. And phase should be 0 too. If that's true, that's awesome. We want to transport the signal from whatever it is, say a preamp output to an amplifier input. Okay, we want to transport that signal with no change. So let's jump into this thing. Let's check a bunch of cables, see what we see. This isn't the see all, tell all, be all. This is just the first very important test. I've got another one I'm going to show you that may be very meaningful and may give you guys like, see, told you. But this one is first step. Let's do it. All right, guys. So today we're going to start testing these cables, okay? And I've got this monster cable. All right, guys, they refer to this as the high resolution LITS cable. That's what's printed on the jacket here. It's got a nice gold braid. Well, I'm sure it's copper wire. Well, at least I think it is. It's gold tipped, pins. Anyway, we're going to try this cable first. So what I want to explain is you're going to see a curve on the screen to begin with. And it's going to be green. I saved it. And you're going to have to kind of guess what wire that is, because I'm going to save that for last to show you, because it's really flat. And we're going from 100 hertz to 40 megahertz. And after that, what we're going to do is we're going to zoom in to probably 100K, okay, maybe even 200K, just to show you what happens at lower frequencies, because 100 kilohertz, 200 kilohertz, pretty low frequency compared to 40 megahertz, right? But I want to go out to 40 meg just to show you what a cable does do high frequencies, which I consider, once you get up in the hundreds of kilohertz or even a megahertz, that's becoming higher frequency. Audio frequencies are low frequencies. So, all right. And anyway, let's get started with this one, okay? Let's do it. Again, we're with the Omicron Lab Bode 100, okay? Very nice machine. Done a bunch of videos on this. Yeah, if you want to learn more about this, go back and watch these. I also have the Quant Asylum, because we're testing this IAMA, but I kind of got sidetracked to kind of go into cables. And I was showing the cables I used to measure this. I showed how the resistors measure so that we feel good about the setup. But then I just thought, while I'm here, why not go into interconnects? Because I have some pretty nice interconnects, and this is one. Now, because it's RCA plugs, what we're going to do is we're going to use these gold-plated jacks, okay? Here, let me show you. All right, guys, so it's an RCA jack with the BNC connection, okay? So I go BNC on this side, RCA on that side. All right, let's plug that in. Okay, let's start the first curve. All right, so here we go. Now, there is a curve up here. Here, let me go ahead and start this one. Well, actually, first what I want to do is I want to show you the setup. All right, so here's the source, top left, okay? 224 millivolts. I've gone up and down, guys. I really can't see any difference. There's a 50 ohm source impedance going out to the cable. And then the cable wraps around and goes in here. So the device under test, the DUT, is this cable. And this is our S parameters, okay? So then we come in here and we have a 50 ohm termination, and it capacitively coupled to receiver 2. So receiver 1's looking on one side of the 50 ohm, and receiver 2 is looking at the other side through the cable, okay? So we should see 50 ohms. We should see a 50 ohm cable. So let's go ahead and measure that. And there we go. So, all right, so the red one is this top right trace, and it's gain. It's in magnitudes of decibels, okay? So you see it coming down. This is All right, so it's coming right here. At 40 megahertz, it's about minus 1.5. Now, I'll come up here and I'll put cursor 2 at 40 megahertz, okay? All right, and then I'll put cursor 1. Okay, it's at 500 hertz. I'll just leave it there, all right? Okay, so cursor 1 is reading like milli-decibels at 500 hertz. At 40 megahertz, it's minus 1.5, okay? So it's gone down 1.5 degrees at 40 megahertz. So that's not bad at all. Now the blue one is this trace over here. It's gain phase. And it is, let's see, that's trace 2 over here. That's degrees. So you can see it started off at micros at 0 essentially. And then it went down to minus 25.6, so 26. And this is the delta, so it's about 25.6, you know. And over here is the delta for the dBs, minus 1.55, let's say, okay? So that's what it's looking like, all right? So what we're gonna do is we're gonna save this one. All right, guys, it's a monster cable, and I have 2 of them, so we're gonna call this the gold monster. All right, let's do that. So, and it's gold. That just by coincidence, it came out gold. That's perfect. All right, so, all right, guys, so here, let's pull this one out, and you know what? Let's do the monster cables while we're here. Let's just do both monsters. Okay, now those, the gold one there, that guy has really tight RCAs. And this one, on the opposite side of the scale, they're pretty loose. Okay, guys, this one's called the multi-phase aligned. I have to get out my glass. It's a multi-phased aligned interconnect from Monster Cable. Made in the US, like the gold one. That gold one is the... All right, I'm going to tell you what this gold one says. It's Interlink High Resolution LITs Interconnect by Monster Cable USA. Okay, so that's what that one's called. So, all right, so let's go ahead and test this guy. We'll call this the red monster. Oh, shoot, my trace, I just left it running. Okay, there we go. Now look at that. Holy cow. That gain really drops down. It goes inductive, right? And then it has a resonance down here, and then it shoots up capacitive at real high frequencies. The cables see capacitance. You know, sometimes you hear audio guys say, oh, that cable's capacitance. Yeah, at 20 megahertz. Not audio frequencies usually, okay? We'll see if we find one. But okay, let me save this one. We're going to call this the red monster. Oh man, that's pretty close to red. I'm going to change it to red though. Just make it easy. Red. Okay, and we're going to call it the red monster. Okay, this time I'll stop it so you can look at the frequencies and they're not writing all that stuff over each other. Which one should we go with next? You know what? I think I'm going to do this IXOS. I-X-O-S. Okay? Not sure how you pronounce that, but it's the gamma. Okay? And this is the bronze. So there's bronze, silver, gold. There's 2 versions above. And look, it was listed at 45 bucks. So I probably bought it because it was on a great sale. So 45 bucks back in the day. Guys, I've owned this for probably 20 years. Really, it's been around for a long time, I think. 15 at least. But anyway, there we go. All right, and this is a 2-meter cable, so okay, it's longer. And let's go ahead and run that one. What do you guys think? It's going to be sweeter than the monster? Wow. Now it's a longer one. The monster is probably a meter, just over a meter. Yeah, that's interesting. Okay, we're going to call this the, well, it's yellow. We're going to call this the white IXOS, okay? White IXOS. And just to remind us, I'll say 2-meter because it is the longest one. And that color is hard to see, so we're going to change the color. And I don't know what we don't have well, we have the green one on top, right? We'll do this color here. And you know what else I'm going to do? Because it's kind of hard to see, I'm going to make the line a little bit thicker. Okay, there we go. Okay, now I'm going to stop it. All right. Whew, man. 20 megahertz or, you know, after 10 megahertz, some of these cables, they really start to change, right? All right, you know what? Since we're doing the monsters, let's do both axes. Now, this is a video cable. This one's also 2 meters, and it's just all wrapped up. But you know what, guys? I've tested some of these cables wrapped up and non-wrapped up. Because they're shielded on the outside, it doesn't seem to matter if they're twisted up. So anyway, this is for video back in the day when you had 3, left, right, and video. So we're going to just use the red one on both ends. And this is going to pull, so I'm going to set it up here so it doesn't pull down on the cable. Don't want to put stress on the connectors. All right, so let's run that. What do you think? Should be better than the, well, maybe it'll be better than the white one. The white one was braided. This one's more of a shielded jacket. But look at that. Now, it's meant for video, so that's probably why they did the shielded jacket, right? Where audio, they felt like a braid. It's kind of, it's a 3-wire braid. Interesting. That's 3, not an even number. So, all right. So anyway, let's go ahead and stop that. And we'll save it. We'll call this a red IXOS. And it's also 2 meters. So I'll just put it there just to, you know, remind us which ones are the long ones. And since we already have a red, I think we'll keep that one purple. Okay. And maybe I'll make a wider trace because there's the pattern. Let's change the weight. Okay. Make it a little bit easier to see. All right, guys. What next? Let's try, I'm saving the expensive one last. So let's try the cheap one before we try the expensive one. Okay, so let's do this guy. Yikes, dropping things. All right, so this is just our cheapo RCA cable, also 20-some years old. It's really old. It's broken in. It took a long time to break one of these things in, so it sounds great. You guys aren't buying that, right? Okay, so here we go. Oh, wow. It's pretty flat. They're starting to get all covered up, aren't they? So you know what? I'm going to turn off the phase just so we can see the gain part. It'll save both. Pretty sure it saves both still. So we'll check on that to make sure. But let's go ahead and stop it. You can see it coming across. Here, let's see what color we're going to make that. Kind of lime green. We'll stay with that, I guess. We're going to do the weight, and we're going to do a heavy one since that's hard to see. And let's change the name of that. Okay, so this is the value. We're going to call it value. We don't want to say cheap, right?
Sorry, I can't do that.
Yeah, you can. Leave me alone. All right, so there we go. There's the value one. Boy, look at that. Pretty darn flat. But you know what? It did drop down quicker. If you look over here on the far left, we're going to zoom in over on this audio band in a little bit, but we're still collecting waveforms. We did the low cost one, right? It's time to do the high cost one. I was just checking to make sure I didn't have another cable around here to test. Yep, this is it. Let's do it. Okay. Now here, let me show you this one. This one's 1 meter. This is the most expensive cable. I'll put a price here, but it's something like $500 US. So, see, I got expensive audio cables, right? What do you think of those connectors? These are the kind you twist down and lock them in so they squeeze, okay? They fit pretty snug before you do that. There's 2 black wires with copper, and there's a silver wire in there. Look at that. So, see? I have high-end cables. It's been in its container. See, the other, its friend is right here. Its partner's right here. If I believed in them, I'd use them, huh? Or wait, I didn't say that. I don't know what I believe, guys. You know, it's the first time I've really tested interconnects, but I really did believe, especially in the interconnects. And we're going to talk about that a little bit more at the end, okay? But yeah, these are the silver streaks. These are really nice. I like the fact they, you know, tighten down, gold connections with silver wire. Is that cool to do? Should be silver connections, huh? No, gold's soft. It mates better. All right, there we go. What do you guys think? Is it my green one that I saved up here? Did I save it for last? Let's see. Wow, look. Whoops, it dropped down. Look at that. All right, guys. We're going to have to turn off some of these guys. Let's focus on this guy. Look at that. Now, where the heck's the phase? Oh, I turned them off, huh? Okay, I turned off phase. Let's turn it back on. Okay, there's phase. Hey, I want to see if I saved the lime green phase. Yeah, I did. Here's a phase down here. The gain's up here. I just want to check that if I don't have it turned on, does it still save? And it does. Okay, I'm going to turn off all the phases for now. Look at the gains. Well, I'm turning the phase back on just because it's going negative. We know it's capacitive. Okay, let's focus on that gain again. Look at that. We dropped about minus 1.5. That's about the same as that gold one, right? The first gold one. Let's see. Look at that. Now, you know what? That gold monster cable I've had for a long time. And that thing is big and beefy. And yeah, pretty cool. So it's doing as well as this expensive, this expensive cable. So they're almost the same. The expensive one, the Kimber cable, I really like Kimber's technology and everything. I like it for the idea of what it does. And does it do it for audio, or is this just for high frequency? Because we are going out to 40 meg and we are seeing some changes. It looks like there's some separation before we get to 10 meg. Where's 1 meg? Somewhere around in here. Where's audio stuff? I guess you can already bet that you already don't see much change down here. So, okay, let's go ahead and save this guy. Okay, I like the gray one for this guy. Yeah, because it does kind of have that black. They are, okay, when you buy this cable, guys, just to let you know, you buy it by length, okay? Back in the day, you get a 1/2 meter. I think it starts with 1 meter now. I'm not sure, but it's got a 1 meter. But it has, you decide which cable or connector you want, okay? And this one has the WBT-0147. And I think it was because it was gold. Now, they've kind of changed the connector, so you can't get exactly this one. It's all black or, different colors. But basically, this one has a black jacket with the gold. So, yeah, see, if you want a pair of these, you know where to come looking. Should I break them in? Let's sit here for a minute. Oh, shoot. How many hours do we need to break them in? Yeah, one guy that sells cables, the break-in period is longer than his return policy. How's that figure? Oh, that's smart marketing. Yeah, that's smart business. I'm not a business guy. All right. I'm just joking around here. So, okay, we got all this stuff saved. What else do I have to test you? Oh, shoot. Where'd this green one come from? Okay, let's turn off the gold one. We got this expensive cable with the green one. Okay. And you know what? I'm going to make this expensive cable bolder. Since it's a nice, expensive cable, it should get a really nice, heavyweight pattern, right? We're going to go that one right there. Yeah, we can see that. Cool. All right, guys. Oh, you know what? I have another cable to show you. Is it the one that made that? I got to loosen these up so I can take them off. They do hold on very tight. And they fit on snug even before you put them on. Where is my other... Here's a cable I made, okay? You guys might be impressed with this. Hey, and by the way, back in the day, when I made cables and stuff, and speakers, I built speakers, I used silver solder. I still have some in my toolbox. Oh yeah, I haven't used it for years. Because maybe I found it wasn't very useful. Anyway, whoa. But I'm an engineer, and I got into engineering because I love the idea of all the little things you can, control and all this stuff, and really got into it. Really wanted all this stuff to be cool and everything to make a difference. So every little thing I did would, you know, make an impact. And okay. Oh, I didn't show you the cable I just put on here. You know what? Hey, before I show you a close-up of this cable, you can see a little bit of it, right? Before I show you a close-up of this cable, let's see how it tests. Oh, crap. Did I say I made this one? Oh, shoot. Okay, let's look at the phase. Oh. Okay, so this is going inductive, right? There's a resonance down here. We could zoom in on that, but I don't want to keep on changing my screen. Okay, you talked me into it. Let's go down. Let's go look at it. I was at -10. I'll go back there. Look at that. It goes all the way down to, what is this, -32. But there's a resonance. And then it goes capacitive. So it was going inductive, and then it went, woo, really capacitive. Wow. The wires, well, I'll show you in a moment. Let's zoom back in so we can we want to zoom in even closer, but I wanted to zoom out enough where you could get enough of the wave shape of some of these other guys. See, in the phase, you can see also the phase changes because it went from inductive to capacitive. Okay, so let's go ahead and save that one. We'll save it. This is the homemade. All right, guys.
Which one?
Leave me alone.
No
Fuck's sake.
problem. I won't.
Holy shit. All right, guys. I made that out of this cable. Okay? Speaker cable, 18 gauge. And then this video, I'll show, you know, nice close-up of each cable, okay? So I'm going to call this 18. All right, so that's 18 gauge speaker cable. And that's a different color red, so I guess we'll leave that. And also, we know it's the one that looks the goofiest. So I'll turn that off, so we're just looking at gains for now. Wow, okay. Let's look at a close-up of this thing. So I put it on these guys so I could put the BNCs on, okay? That's how I did that, just twisted them in there. But look, it's just speaker wire, okay? That's all it is, just speaker wire. Tested pretty awful, huh? Okay, you know what? Let's not jump to conclusions yet. What else do we have? Okay, guys, I have this cable. I'll show it to you. I'll tell you what it is later, okay? It looks like just your typical BNC to BNC, right? One of the readers, one of the commenters, suggested I use a cable like this. So, or he said that he made cables out of this. So I thought, wow, you know, I'm going to try it. So here, let's put this on here. Let's see what we get. That's our green one. I'll turn off these other guys so we can look at it nice and close. I'll turn off the green one. That's it, guys. Nope, let's turn on the phase. Thing about phase is, you know, when you have gain that drops 3 dB down, as it's coming approaching 3 dB, if you're hand drawing a graph on a graph paper, then at 3 dB, like let's say you design a filter to roll off at 20 kilohertz, 40 kilohertz. Then at 40 kilohertz, you go down and you put a little dot there, and that's your 3 dB point, right? And then you come across and then you just kind of hit that dot, and then you go 20 dBs per decade down, okay? So kind of aim for that dot and draw that. For phase, when you're drawing the phase, you go, okay, down that dot, I'm going to change my degrees up or down from 0, depending on the capacitive or inductive. You go up or down, and you go 45 degrees and put a dot. And then, so you're going to go that 45, you're going to come over and hit that 45. So you're going to start changing sooner so you can hit that 45, and you keep on that kind of curve, that arc, and you eventually go down to 90 or up to 90. Okay. So to help you draw it, you go down 45 degrees. So what I'm telling that for is that when you're looking at a curve, you're going to start seeing the phase change really early because it has to change 45 degrees and it's going to end up at 90, but it's going to change 45 degrees, half its change when it gets to 3 dB, because 3 dB is that, you know, that half voltage thing, or what we call it. You know, it's the half power mark. It's really, it's not half voltage, it's 0.707, right? But it's half power, so 3 dBs. So the decibels only changed 3 dB, but the phase changed a lot. So I say that because when you look at the phase here, I'm going plus or minus 90, just in case we had a really inductive or really capacitive curve. But look at that, guys. It looks like the phase might be changing positive 5 degrees. Wow, that's not very much, huh? All right, so you know what? That was awesome, right? Oh, hold on a sec. Before I change this, here, let's save this. We got to save this guy. Well, I saved it. It was the green one, right? Sorry. Let's come up here to the green one, and we're gonna say coax. We're gonna just call it coax. I'm gonna tell you what coax it is later, and I'll say new because it's my new coax. And I'll tell you what I paid for it and all that kind of stuff. I'm gonna delete this guy I just added. All right, so let's go ahead. So that was my green one. That's how I started. That was my reference cable. Reference, not my Silver Street cable. Well, you know what? That's in this test, right? We got some more tests to do. So let's go ahead and zoom in on this test. You know what? There's one more thing I want to show you. I wanted to grab my BNC to BNC that I used that came with the Omicron and just see how that one tests. And look at that. It's not quite as good as I would have thought. The gain is absolutely flat, but look, it's already changed about 40 degrees, but look, it's almost a linear ramp, it looks like, right? Now, that's interesting. So it's interesting that right from the get-go, we're going, the phase is just kind of slowly changing, just, you know, pretty much just a ramp straight up, right? And it went positive. So inductance is, so it's looking more inductive on this one, right? And you know what? I'll save this guy. I'll go ahead and save it. And I'll call this one, well, I'll call it the Omicron. Okay, it's the Omicron coax. All right. All right, guys, I want to try one more coax. I mean, that's the thing, these coaxes. This one actually has a label. This is actually an RG58, says right on it, high quality coax cable. And I think this came with, you know, one of my matrix, or might have came with my Uni-T generator, I'm not really sure. But yeah, let's try that one. Just for fun. Gotta try a couple cables because, all right, so here, let's turn off this Omicron because it's the same colors I'm drawing. Look at that, just totally flat. So this low cost, pretty sure this one came with I think this came with my Uni-T generator. And man, look at that. That thing is just flat. Okay. So we've already got a flat coax. So let's just go with that. I mean, I won't save another one. All right, guys, you know what? Before I take this off of here, what I want to do is I'll just let this run while we're talking. And what I want to do is I want to go here and go down to 200 kilohertz. I was going to go down to 100 kilohertz because a lot of times I do tests out to 100 kilohertz just to see what's going on with an amplifier, how sometimes the bandwidth on these things are pretty wide. So even though we can't hear it and all that kind of stuff, I just want to see how the cables are going to perform, right? And also, if there's any argument that harmonics of some of the audio stuff at 20 kilohertz, you know, the first few harmonics are going to be out in the 100 kilohertz range, right? And if that has, like, one guy was saying, well, we might not be able to hear it, but maybe we can feel it. Those high frequencies, I really doubt it. Really low frequencies we can't hear, I think we can feel, but high frequencies, not so sure about that. Anyway, so just because that, I usually go out to 100K, but let's go to 200K just to see Okay, down here on the right, we're 200K. And look at that. This coax is just absolutely dead flat. Okay, now what I want to do is I want to turn on the green one. That first coax, look, dead flat. Let's turn on the gold one. Wow, again, dead flat. Red one, red monster. Okay, you know what? Instead of plus minus 10 dBs, let's go down to 3 dBs. What the heck? Plus minus 3 dBs. All right, I think I'm going to do 1 dB. Let's do that. Let's see what fractions. Okay. Here, I'm going to turn off this guy scanning because maybe it's in our way. And I'll back up. Okay. So that last coax, look how flat it is. Now, here's this green one. It's slightly above the line. Slightly all the way across. The gold one, it's just barely below it, I think. The red, right on it. It's just dead flat. The white onyx, slightly above probably. Does it cross over? Maybe it crosses over. Oh, I'm going to turn off the phases because that's going to make things harder to see. Won't be able to tell which one's gaining phase. Okay, let's go look at red. Geez, guys, I feel like I really need to zoom in closer to. Let's go down to 4, plus minus 4. Okay, plus minus 2. I think we got to go down even closer. Okay, there's plus minus 2. I'm going to start over again, guys. I want to turn them off so we can see them. We can see how we light up the screen. Okay, I'll turn off this red trace. Whoops, I guess I have to turn it on. I guess I have to leave the last trace on there, huh? Let me run it again. All right, I'm going to stop it so it's not bothering me or you guys. Okay, the green one, look at that. 20 milli. And it slopes up slightly. The gold one, the gold monster, actually a little bit flatter than that new coax. The red monster, it starts up above and then it drops down below. But guys, we're talking plus minus 20 milli. Okay, let's go to the white axis. Turn that on and off. Look at that. That thing looks great. Boy, that white one might actually be the flattest and closest to the 0 line there. Except for that coax that we're just running. Okay, here's the red. Oh, here we go. The red axis. Holy cow, that real long coax version of the video one. Okay, so here's the value cable. Look at that. It's negative. Starts off negative and goes a little bit more negative. All right. It's the furthest one away from everything. And this was the Kimber cable, Silver Streak. Okay, there's this Silver Streak Kimber cable. Okay, I'll just put Kimber. All right, guys, that Silver Streak looks pretty darn good too, right? Okay, let's go to 18 gauge speaker wire. Uh-oh. So far, everything's looking pretty close. We're going to go to 60. Plus minus 60 milli. That's crazy. Now, where's this red one? Oh, I see it now. Holy smokes. You know what? We got to make it a fatter trace. Wow, that is impressive, guys. Look at that. That is crazy. Man, I mean, just for speaker wire, that is looking pretty darn good. That's actually better than that coax. So at low frequencies, things are looking different, right? High frequencies. So guys, here's the thing. A lot of times people are talking about skin effect, all these high frequency components, all these buzzwords they hear from EMI guys, signal integrity guys, people like myself that are worried about high frequencies and the kind of designs we do. They use all these buzzwords and I'm like, oh man, those things don't mean anything in audio. But you know what? By trying to use the buzzwords and trying to sound cool and trying to act like we understand technology and throwing out these words some of these people have learned. In engineering, you have to focus on what's important. And what's important is the frequencies of interest. Down here, and look at this. When you look down closer, because that cable I bought, Okay, this cable looked great at 40 megahertz, but when you look at just the frequencies that we care about, then all of a sudden, other things start looking better, right? Now, that cable actually looks worse than my speaker cable. Okay, here, okay, we're gonna have to zoom in again. I'm gonna go a little closer even. We're gonna really zoom in so we can try to spread these things out. Okay, so the value cable, it started minus 20, it's going off, okay? Because I want to zoom in on these other ones. So the value cable is looking the worst, furthest one away, right? Actually, this other green one, the coax, guys, that coax is not looking. Now, come on, we're looking at these milli-decibels. This is ridiculous. This is like microvolts kind of stuff. This is really teeny stuff. So it's probably, none of this is probably meaningful, but I'm just saying, if you want to compare things, you have to do it this way, right? So which ones are looking the best right now? This purple one that started off right at 0 and dropped down a little bit, that red axis, which is a video cable, which is essentially a coax, except for RCA connectors on the end. Man, that cable, that's starting to really impress me. Okay, what else looks good? This cyan color, this light blue one, that one looks great. That's the white axis. So holy smokes, the axis cables are looking great. Now this cable here, this orange one, oh wait, hold it. When I go over it, see how it highlights the red monster? Let's make the red monster fatter. There we go. So that's actually when you go over the cable over to the right, you see the little blinky. So that's the cable. So actually, red monster starts a little bit above, and then it goes. But then again, okay, guys, we got to go down to 20 kilohertz. We really need to look at this first window, right? So the purple one, the red monster, the axis, this 18 gauge speaker wire is looking really good. The expensive cables up here. Okay. When we were spread out looking at 40 megahertz, that coax and some of these other cables look great. But as we zoom in to 200 kilohertz, all of a sudden other ones are starting to look better. But then, as I'm trying to say which ones are better, then it's really like if I look down at 20 kilohertz, that's where we have to start. So let's zoom in again. Before we do that, let's just look at the phases. I'm going to turn off the gains and look at the phase. The phase at this point, guys, all the phases are flat. There's 0. There's no phase shift. Oh, but you know what? We do have, we're going plus minus 90. So let's go ahead and get a little closer than that. We'll go 30 degrees, okay? Plus minus 30 degrees. All right, plus minus 10 degrees. All right, it's starting to get kind of stupid. Should I go all the way down to 1 degree? Holy cow. Yeah, this is getting kind of crazy. Okay. Woo, look at that, man. At plus minus 1 degree, we start to see a difference. At 200 kilohertz, the value one is looking kind of terrible. It's the worst. Well, I don't want to say terrible. It's the worst of what we're seeing. The cyan color, the y-axis next, and then the other axis, the red one, and then the red 18 gauge speaker wire and the red monster the next. And then this gold one, the gold monster's pretty square. Okay, now we're the silver streak. That's looking like pretty darn good too. But then we have to come up to the coax, and what else we have in here? The Omicron coax. So yeah, some of these other ones are looking a little bit better. Okay, now let's go to 20 kilohertz, guys. Let's just get down to business. All right, 20 kilohertz, man, guys, it's less than 0.1 degree phase shift. Some people say you can't hear phase shift. really agree with that. I think maybe low frequencies, it's very difficult to tell a phase change, but at higher frequencies where things are happening quicker, I think you could. And, you know, 4 or 5 kilohertz, you know, where we can hear really well is right here where my cursor is, and there's hardly any phase shift at all with any of these cables. Dare I say we're working at audio frequencies. Hate to beat a dead horse, but guys, this is audio frequencies. We're looking for differences. We're going to continue looking, okay? But I'm just saying, for the gain, as far as the gain goes, it's looking like it doesn't matter, right? Let's look at the gains, the actual gains. That was phases. Okay, now the gains are spread around, okay? Here's 0, purple. The red axis, that video cable, is dead on, right? That one looks the best. That's almost exactly 0. Okay, now a little bit above red, or a little bit above the line, at 10 milli is red monster. And then above that is the white axis, and then there's the 18 gauge wire. The 18 gauge wire, guys, is beating the silver streak. Seriously. And you know what else I have? I have another one I made where I twisted the wire. Okay. Yeah, that was just wires side by side. Guys, the wires side by side, magnetic fields, they do cancel, especially at these low frequencies. It's not, the twisting doesn't make as big effect or any effect at all at low frequencies, which is audio. So, guys, the one that's furthest away is that coax, the one I was so proud of, the one that did so well across the 40 meg bandwidth. This guy was a champ. He's a champ. And you know what? If you care about high frequencies, you can't hear anything, this is a champ right here. Okay? Put a couple of these guys, put a couple of those on there. BNC to RCA, and you can make any coax cable your friend. All right, guys, what do you think of my shirt close up? All right, so guys, I mean, we're down here at plus minus 40, and most of these things are, well, they're within plus 20 and minus 25 maybe. So, whew, the value cable is down at minus 20. Not looking too shabby as far as the gain, right? And the phase in this frequency band at 20 hertz. Let's turn off the gains, turn on the phase, and look at those. At 20 kilohertz, they're within what, 0.1 degree. Holy smokes. So guys, yeah, music's not sine waves. You know, it's a compilation of all these sine waves, but they're all within this frequency band. So this is where they live. Doesn't matter if you put in individual frequencies or a bunch of frequencies together. They all live within this frequency band. They're in this bandwidth. Pure and simple. You don't add 2 frequencies and get something outside the hearing range. Okay? So you get beat frequencies and harmonics and things like that, but that's distortions, right? As far as music goes, it's in here. Now, again, we went down to 20K. Let's go to 100K. Okay, 100K, we're within still fractions of 1 degree. That's 0.5 degrees. Okay, now let's look at the gains. And there's the gains. Wow. So I hope this gives you an idea. Now this is, again, this is one measurement. This is gain, okay? Hey guys, so what do you think? Hey, give a like to the video if you liked it, if you found anything useful. Really appreciate that. Helps a lot. Subscribing helps a lot. And if you think you're subscribed, just check, because I've heard YouTube unsubscribes people. So yeah, appreciate you checking on that. That's important to the video or to the channel. And also, there's a super thank you button. you know, you want to buy me a cup of coffee, a beer, I feel like doing a rant. There's a couple of channels that have done some measurements and or talked about them, and I think I'm gonna do a little rant about that, just to so I don't make this video too long. But anyway, yeah, we're gonna talk about. I think in that rant I'll just talk about testing and all this kind of stuff. But let me know what you guys think, okay? I got another video that might turn into 2 more, but I got another video that I think I might be able to show something about these interconnects that could make a difference. But so far, guys, it's less than a degree phase shift, right? That's, you can turn your head just a touch and get that kind of phase shift. The impedance is just so low, and it really, at the audio frequency, you can see how the cable, none of the cable, I mean, there's such microscopic differences between them that it doesn't really, you know, it's hard to say that anything can make an audible difference. I think you'd agree. Let me know what you guys think, though, okay? Give me your comments below. I've got a couple ideas in the next video that I might be able to show something. I'm not sure yet, but I might be able to. So we're gonna continue testing these cables just because I really want to drive this home. All right. Speaker cables I think are going to be even more interesting. Even though interconnects are so important, the signals are small. You think the signal integrity is so important, but man, we're just not sending the signal very far. And all right, guys, I guess I'm going to sign off so I don't make this video too long, but thanks for watching. Like the videos, join the channel if you'd like that. That'd be a big help. I appreciate my patrons and the members of my channel. Danny, 2 big thumbs up to all you guys. You know, when I'm buying all these cables and interconnects and stuff for these videos, I really appreciate it. And yeah, that's, I mean, I can't tell you how much I appreciate that. Hey, and by the way, we just had a 4th of July weekend. Happy 4th to all you Americans or whoever celebrates the 4th of July. And yeah, I hope you had a great weekend. I've been home testing cables all weekend. I did go outside in the yard and I got a lot of allergies and my eyes got all puffed up and stuff. So I might have, you know, but I didn't want to put off the video. Even that I looked all puffed up and stuff, I gotta get a video out, right? And I wanted to get this video done because I spent a lot of time doing it. And when time goes by, I start losing track and I start doing too much testing. So kind of had to call it quits on this video. I got another one coming out on this, which I got to continue the testing. Yeah, I really want to see if I can find something that makes interconnects audible. Okay. Hey, thanks for watching, guys, and we'll see you next time. All right, it's the monster cable, and unbelievable, fucking believable. I was working.